Okay, in this section 2.3.2, we're going to solve linear equation involving fraction. These are much more complicated than simple whole number linear equation. So we need to have a strategy avoiding directly deal with fraction. Here, as you can see, +3 and +3 on both sides. Actually, what you can do, subtract 3 first. That will get you out of these two numbers. So you get into, by the way, this is our, in our textbook, exercise 62 example. When you subtract 3, this is both cancel out. So you have left hand side this, right hand side this. You want to solve x, but involving fraction. So there are two approaches. You can find the LCD, LCD for all three of them. Approach number 1, 6, 6, 6. Using LCD, 2 becomes 6, which means multiply by 3. So your numerator multiplied by 3 also. That will be 3x. The first fraction change into 3x over 6. Second fraction, 3 becomes 6, you multiply by 2. So 2 times 2x, 4x. The third fraction, it's assuming a 1x, x over 1. You want to change into denominator 6, so you multiply by 6, that will be 6x. 6x here. Okay. Then, after this step, you can multiply by 6 both sides for every term, each term multiply by 6. You will get into 3x plus 4x equal 6x. Okay? 3x, 4x equals 6x. And then combine like term. 7x equals 6x. You see the same variable on both sides. You just isolate that into one side. So you have 1x. This side becomes nothing, 0 there. In the solution, x equals 0, using same denominator. This is approach number 1. If you use the other approach, you can multiply LCD 6 for each term. At this step, okay, let's erase that. If you multiply by 6, 6 times x over 2 plus 6 times 2x over 3 equals 6 times x. This using multiplication property of equality. That 3. This is 1 and 2. So as you can see, 3 times x, 3x. And then 2 times 2x, 4x. And then 6 times x, 6x. This will be, will be the same as the previous example. Eventually you get x equals 0. So you have two approaches. You use same denominator and then clear and then drop your denominator. Or you can use multiply LCD for each term to clear the fraction. So two ways actually very similar. Okay, this is our example number 1, exercise number 62. Let's erase that one. Get into our second example. 2x over 3 equal 2 minus 5 over 6x. This is obvious, we're going to solve x. So we can approach number 1. So use 6 denominator. Each term, as you can see, this is assuming 1 on there as a denominator. So 3 becomes 6, you multiply by 2. 2 times 2x, 4x. For this term, 2 equal that. 1 times 6, 2 times 6, that's going to be 12. So 12 over 6 is equivalent to 2. The last term, you don't change anything. Okay? So that's 5x here. And then you can go ahead and drop this. Okay? That's equivalent like multiply by 6 all term. And you get clear the fraction. So 4x equal 12 minus 5x. Here. Then we want to isolate our the variable one side, plus 5x, plus 5x. You get 9x equal 12. And then you divide it by 9. So x equal 12 over 9. This is a fraction. But at the last step, you always check if there's anything you can reduce. In this case, it is reducible. So you divide it by 3, you get 4 thirds. Okay? This is first approach. You are find the LCD, changing the fraction like this, and then reaching to your solution. We have a second approach. You can multiply LCD 6 for each term, like this. 6 times 2 minus 6 times this fraction, right over 6x. You can see, put a 1 down here. That's 2 here, 1 here. That will be 2 times 2x, 4x. This one is 12. And then down here, cancel this 6, you get minus 5x. This will reach into the same result as previous example. You go from this step, same process, getting to 4 over 4 thirds. That's how we handle the fraction. We have to find the LCD, get into that, and then clear the fraction, and then go deal with the whole number. Okay?